Today we're going to talk about the different kinds of solutions that you can have for a system of equations. You can have one solution, infinitely many solutions, or no solution. So we're going to make a foldable for that. What I need you to do is take your colored sheet of paper that you picked up. I need you to pull out your notebook. What I want you to do is take your paper and line it up so it's only as long as from the top line in your notebook to the bottom. Mark the extra. See, I just folded it over the edge and it made me a nice little line. And you're going to trim that off. I'm going to fold mine down so it gets a little bit more structured and my line is nice and neat. So that's the extra paper. I'm going to use my scissors and I'm going to trim that down a little bit. Apparently I'm quite terrible at cutting. Okay. Then after you trim it down, you should have a sheet that looks like this. The side that you cut will be the side of your foldable. So you're going to take your paper and you're going to fold it in half. So this is the side that I cut up here at the top. I'm going to fold it in half like this. And then after I fold it in half, I'm going to fold it 3 ways. It's kind of like you're folding a letter for an envelope. You want to fold it so your 3 pieces are about the same length. They're about the same size. It's not going to be perfect, but it'll be close enough. So it looks like this. So when you open it up, you should have 6 little pockets. Now out of those pockets, I want you to take the top 2 flaps, and actually I'm going to flip mine over so it folds, see how it kind of lays down a little bit better. And I'm going to cut those top 2 flaps up to the fold. Okay, just like that. So I have a nice foldable and it has 3 windows. Each of these should open. Now we're going to talk about the 3 different kinds of systems, and we are going to use 3 different methods to solve. Oops, that's the wrong pencil. So let's start with the very first system. So in this flap, I want you to write on the outside 1 solution. Draw a picture of a coordinate axis. It's just a sketch. It doesn't have to be perfect. Just your XY axis. Label it X and Y. Oops, I apologize. That should be Y. And then you're going to draw 2 lines on it. And all you have to do is make sure that your 2 lines meet. Anytime you have one solution to a system of equations, the 2 lines on the graph will meet at exactly 1 point. So you'll have exactly 1 point where they meet, just like this, okay? Then after you do the first flap, move to the second flap. At the very bottom, write no solution. Draw a sketch of a coordinate axis. And in this case, anytime you have 2 lines that never meet, you guys should already know this because you have some previous knowledge, but those lines should be parallel. So sketch 2 parallel lines. Oops, I meant to do those in different colors. I apologize. 2 parallel lines. And again, it's a sketch. It doesn't have to be perfect, as long as we get the idea that they're parallel. And you can write even underneath that those are parallel lines. Oh, I can't spell parallel either. Jeez. Okay. On the last flap, Maybe I should zoom in a little bit. On the last flap over here, I want you to write infinitely many solutions. Again, I'm going to draw a coordinate axis. I'm going to label it Y and X. And this time, all I really have to draw is one line. Because for it to be infinitely many solutions, what it really means is that you have two lines graphed on top of each other. They're the exact same line. And you can even write a little note to yourself, same line. The two lines are exactly the same. And the way we denote this is by showing double arrows at the end. The double arrows at the end says that's actually two lines. So let's go back to the first one. One solution, open up the flap. We're going to solve this example by graphing. So write graphing at the top. The example that you have is the system. Y equals -1 and y equals -5 halves x plus 4. We're going to graph just like we know how. We're going to pull out slope and y-intercept. For the first problem, there is no slope shown, so my slope is 0. This is a horizontal line. It's like 0 over 1. So I'm going to go up and down 0, but to the right 1. And my y-intercept is a -1. Then for the second example, my slope is a -5 halves, which says I go down 5 to the right 2. And my y-intercept is a +4. You should have picked up a little sheet of graph paper to make this foldable. So on that graph paper, I'm going to draw my coordinate axes. And then after we do this, we'll glue it down so it stays still. I just don't want to glue it first because it makes it hard to write on. I'm going to draw my coordinate axis. I'm going to label it Y and X. I'm going to count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You get the pattern. I'm counting by ones but labeling by twos. I'm going to graph the very first line in one color. So my first line is y equals -1, which says I start at the y-intercept of -1. And it tells me to go up 0 and to the right 1. So I'm just going to keep going to the right and putting points. And you only need 3 to draw the line, but you can go and do as many as you'd like. As you can see, that is an exactly horizontal line. Just like this. And then on that line, I'm going to write the equation y equals -1. And I'm going to graph my second line in a different color. My y-intercept is a +4. My slope tells me to go down 5 to the right 2, down 1, 2, 3, 4, 5. To the right, 1, 2, and I can see that it hits this line right here. Then I'm going to go down 1, 2, 3, 4, 5, to the right, 1, 2 again. I have 3 points on my line, so I can draw my line. After I draw my line, I'm going to put my arrows in either end. And I'm going to write the equation on the line. I'm going to write it up here at the top. Y equals -5 halves x plus 4. And then after I graph, I can see that my system meets at the ordered pair -1, excuse me, 2, -1, which is right here. It meets right here. So the solution to this system is 1 point and that solution is 2, -1. It has one solution. Now I'm going to take my graph paper and my glue stick, which all of you should have a glue stick. And I'm going to glue that onto this foldable. Oops, put a little too much glue on it. Right here. Okay. Then after you do that, all you need is a little bit more notes. I want you to reiterate that this has one solution, so write it again. Anytime you have a system that has one solution, this system is considered to be consistent.